When the clock runs too fast, telomeres and the burden of chronic disease. It begins quietly. Deep within your cells, the telomeres, the tiny protective caps at the ends of your chromosomes, are shortening, one cell division at a time. For years, this silent process may go unnoticed, invisible even to the keenest medical eye. But as the protective sequence wears thin, the consequences ripple outward, touching the health of the heart, the brain, and every organ in between. The link between telomeres and chronic disease first emerged when researchers noticed a curious pattern. Patients with certain illnesses seem to have unusually short telomeres for their age. It wasn't just a coincidence. Telomeres, after all, are more than passive structures. They are guardians of chromosome stability. When they become critically short, cells can no longer divide safely, triggering senescence or cell death. In tissues that rely on constant renewal, such as blood vessels or immune cells, this can lead to functional decline. Cardiovascular disease was one of the first areas where this connection became clear. Imagine the arteries as highways carrying life-giving blood. Over time, the smooth inner lining can be damaged by high blood pressure, cholesterol, or inflammation. The body sends in repair crews, cells that replace damaged tissue. But if their telomeres are short, these cells arrive old and weary, unable to keep up with the repairs. This accelerates atherosclerosis, narrowing the arteries and raising the risk of heart attack or stroke. Studies have shown that individuals with the shortest telomeres face significantly higher risks of such events, even after accounting for traditional risk factors. In diabetes, the story is similar but unfolds in a different landscape. Chronic high blood sugar generates oxidative stress, bombarding cells with reactive molecules that damage DNA, including the telomeres. As pancreatic beta cells lose their regenerative capacity, insulin production falters. Meanwhile, short telomeres in immune cells impair the body's ability to manage inflammation, feeding a vicious cycle that deepens the disease. Cancer presents the telomere paradox. On one hand, short telomeres can suppress tumor formation by halting the division of damaged cells. On the other, critically short telomeres can lead to chromosome instability, a fertile ground for mutations that drive cancer. To thrive, many cancers reactivate telomerase, the enzyme that rebuilds telomeres, granting them the unnatural ability to divide indefinitely. In this way, telomeres play both the hero and the villain, depending on which side of the cellular battlefield you stand. Neurodegenerative diseases like Alzheimer's add another dimension to the story. The brain's neurons rarely divide, but the support cells, astrocytes and microglia, must maintain healthy function over decades. Short telomeres in these cells are linked to chronic inflammation and reduced ability to clear toxic proteins, processes believed to accelerate cognitive decline. This is why telomere length is now being studied not only as a biological age marker, but also as a predictive tool for disease risk. It offers a glimpse into the body's cellular reserve, how much time the cells have left before they falter. While genetics sets the baseline for telomere length, lifestyle and environment can accelerate or slow the ticking of this clock. Chronic stress, pollution, poor diet, and lack of exercise all push it forward. Conversely, regular physical activity, antioxidant-rich foods, stress management, and quality sleep can slow its advance. Yet despite the growing knowledge, telomeres remain enigmatic. They do not determine fate in isolation. They are part of a complex network of biological systems. Protecting them may not guarantee freedom from disease, but ignoring them could mean watching the clock run out too soon. And so the story of telomeres and chronic disease is one of balance, between renewal and decay, between repair and breakdown. They are the timekeepers of our cells, and when they falter, the entire body begins to feel the weight of lost time.